together. And what I wanted to do this evening in this video is to do a difference in means hypothesis test and calculate the t-statistic, because in the past videos we've made on hypothesis tests, we did one for means, but we did one with a base mean, and then we calculated another mean, and then we decided whether that mean would accept the null hypothesis or reject the null hypothesis. But in this particular video, what we're going to do is we're going to take two different means and we're going to compare them to see if they accept the null hypothesis or reject it. So it's a difference in means hypothesis test. And one data set has 100 male Olympians and the other contains 100 female Olympians. And they want to know, is there a significant difference in average height with a significance level of 0.05, and your significance level is also your alpha. And then so your null hypothesis is the male mean equals the female mean, and the alternate hypothesis is the male mean does not equal the female mean. And this is going to be a two-tailed test. So we're going to import the libraries that we're going to need to carry out this test. So we're going to import NumPy as NP, and SciPy. From SciPy we're going to import stats. So the heights of the male Olympians, the heights male equals np.random.normal. 183 is the average height, and 10 is going to be the standard deviation, and 100 is going to be the number of random samples. And then we calculate the heights of the females Olympians, and we do a random selection of 170 centimeters is your mean, 9 is your standard deviation, and you have 100 samples. So now what we're going to do is we're going to calculate the sample means with the standard deviation. The mean male equals np.mean heights male. STD male equals np.std heights male, and degree of freedom equals 1. And n male equals the length of heights male. And then we do the same thing for the female. So we get the mean female, the STD female, and the N female. Now what we do is we calculate the standard error. SE male equals STD male divided by NP dot square root N male. SE female equals STD female divided by NP dot square root N female. And standard error equals NP dot square root SE male squared plus SE female squared. And now we're going to calculate the t-statistic. Okay. So your t-statistic equals mean male minus mean female divided by standard error. And now you're going to calculate your degrees of freedom. So your degrees of freedom equals SE male squared plus SE female squared, and then that's going to be squared, divided by SE male squared, which is squared again, divided by N male minus 1 plus SE male squared, which is squared again, divided by N female minus 1. Now we're going to calculate the p-value. P-value equals stats.t.sf, and SF means your survival function. Brackets np.ab, t statistic, comma, df, and it's a two-tailed test. And that's why it's multiplied by 2. And then now we're going to print the results. We're going to print the male mean, the female mean, standard error, t statistic, t criticals, degrees of freedom, and the p-value. So you can see the male mean is 182.05 when the population male mean was 183. The female mean was 170.38 when the population female mean was 170. Standard error is 1.39. Your t statistic is 8.42. Your t critical is 1.97. Your degree of freedom is 196.06. Your p-value is 0. And now what we're going to do is we're going to determine the critical value. So alpha is 0.05, which is your significance level. T critical equals stats.p, which we've already talked about that. Stats.p, 1 minus alpha divided by 2 over f. And then we're going to have a conclusion. If NP-abs T statistic is greater than T critical, then you reject the null hypothesis, and there's a significant difference in average heights. So the T statistics is 8.42, and the T critical is 1.97, so that's greater than T critical, which means that you have to reject the null hypothesis. And that really, to be perfectly honest, it's a no-brainer, because you know if the male mean is 183 centimeters and the female mean is 170 centimeters, then you know that the two means are not going to be equal each other. But we had to go ahead and do this exercise so you can see how it works. But let's just come over here a second and let's make the female mean 180. Okay, and then let's run it. And we're just running that now. It says T critical is not defined. Well, it worked before, so obviously I've done something. So let's try it again. It says failed to reject the null hypothesis. There is no significant difference in the average heights. So you can see that when we changed the female's height to 180, there was no significant difference. So it failed to reject the null hypothesis. But when we change it back to 170, then we reject the null hypothesis. And then the next thing we do is we use matplotlib to plot the distribution, so you can see the male Olympians and the female Olympians, and the male mean is 181.54 and the female mean is 169.99. And so you plot that on a graph as well. So that's how you do your difference in means hypothesis tests. And I just wanted to calculate that for you so you can see how to do it. So I'm going to go ahead and close this video because we've talked about what we wanted to talk about. If you like my video, please like and subscribe, and I look forward to making another technical video for you in the very near future.